Hello, welcome back. So we are in the new activity of the chapter 9, activity 11. So in this first activity, we are implementing the Max RGB filter. So we know that the filters allow and block signals or data depending on some criteria. So manually, we are going to write the code for implementing a special filter based on the value of the intensity of the colors. This is known as the Max RGB filter. So we compare the intensities of the color channels of a color image for every pixel. So first of all, we keep the intensity of the channels with the maximum intensity. The intensities of the channels are set to 0. This happens for every pixel. So we are supposed for a pixel, the intensities are between 30, 200, and 120. So then, after applying the max RGB filter, there will be 0, 200, and 0. So let's take a look what happened when I run this program. So as you can see, this is the camera, and this is the RGB effect with the filter. So I'm gonna move the camera a bit. So this is the color gray that is detecting with the camera. So see you in the next activity. Hello, so now we're in the next activity. This is implementing a background subtractor. So the static cameras are used in many applications such as security and monitoring. We can separate the background and moving objects by applying a process known as background subtraction. It usually returns a binary image with a background. The static part of this is in black pixels and moving, changing, or dynamic parts in white pixel. OpenCV can implement the Taught 2 algorithms. The first is create a background subtractor. This creates a k nearest neighbor background subtraction object. Then we can call the apply function with the object to obtain the foreground mask. We can directly display the foreground mask in real time. So I'm gonna run the program so you have a better look of this subtraction background. So as you can see, in this frame you can see the subtraction of the background. It's like a security camera, and as you can see, it's in black and white. So see you in the next one. Hello, so now we're in the activity number 3. This is another similar function to create a background subtractor. In this case, we are using the function cv2.create a background subtraction mach2. This also generates a background mask using the apply function. The following is a sample of a program using it. So as you can see, we are using the create a background subtraction mach2, and we are also using the fog mask. So the preceding program and view the output. In both programs, we are creating the FGBG object and using apply function to compute the foreground mask. That is the FG mask. Then we are just displaying the foreground mask in real time with the amshow function. The expected output of this code can be seen in the preceding screenshot. So first of all, I'm gonna run the program. So as you can see, it's also the same effect. So it's a background subtraction. This in this case is the mach2. So it's very similar to the first activity. You can see. I'm moving the camera. And it's creating this effect. So see you in the next one. Hello, so now we're in the activity number 3. This is computing the optical flow. Optical flow, also known as optical flow, is a pattern that appears in motion of objects in a video, live or recorded. So the appearance in the previous sentence, this means that if the observer, in our case the camera, is in motion, then the objects in the scene are also considered to be moving, even if they are static. This is known as relative motion. In brief, the optical flow highlights the relative motion in the video. OpenCV has implementations of many of the functions that can compute the optical flow. The CV2 cal optical flow far-back function computes the optical flow with the dense method. It means that it computes the flow for all the points. This function implements the Gunner far-back algorithm. So I'm gonna run the program. And I'm gonna move the camera. And as you can see, it highlights the objects and also moves with the motion of the camera. So it creates this effect that is very difficult to see the objects of the image, like with motion blur. So see you in the next one. Hello, so now we're in the activity number 5. This is detecting and tracking motion. So we're gonna build a system for detecting and tracking motion in real time with the RPI OpenCV and Python. We will use a very simple technique to detect motion. Basically, we will compute the difference between the successive frames of a video feed, a video file or a live record from the USB camera. Then we will plot contours around the area of the pixels to wish to detect the difference between the successive frames. So in the beginning, we're importing the CV num as also initialize an object corresponding to the USB webcam. In this case, we're importing the CV2, the import num as MP, and the cap equal to CV2 video capture. Then we have to apply the deletion operation to the frames in the video. We need a kernel function for that. We will define it before the video loop. Let's define it as the false. So we are using the k equals to mp point once, and inside the parentheses we are putting 3 and 3. Then we have to put mp point unit 8. Then the follow code captures and stores the successive frames in separate variables. T0 equal to cap point read in 1 and T1 equals to cap point read in 1. Now I'm gonna move this a little bit. Now let's write a block of code in a while loop. In this block, we compute the absolute difference between the frames we captured earlier. We're going to use the cv2.abcdiff function for this. Then we will convert the computed absolute difference into the grayscale to process it further. So first of all, we have the while true. Then we have the d equal to cv2 absdiff t1 t0. And then we have the gray equals to cv2 cvt color d cv2 point color bgr to gray. So we are converting the RGB to gray. And I'm gonna run the program so you can see the output. So you will see something with black and white. Hello, now we're in the activity number 6. This is detecting barcodes in images. A barcode is a way that information is represented visually and is easy to understand for purpose-made machines. There are many barcode formats. The usual format has parallel vertical lines for different thickness and different amounts of space between them. In this section, we will demonstrate how to detect a simple parallel lines formatted barcode from a still image. We still use the following image of soda can. So, I'm gonna run the program. And as you can see, it's detecting the barcode in this image. So, see you in the next one. So now we are in the activity number 7, implementing the chroma key effect. The chroma keying is also known as chroma key composing. It's also colloquially known as the green screen or blue screen effect due to the green or blue background. It's a post-production technique and also be used in still image and live videos. In the chroma key effect, we place an object or a person in the foreground and capture an image or footage. The background is usually a green or blue color fabric or wall. Then we replace the green or blue color in the captured image or footage with another video or an image. This makes the viewers feel that the person or the object in the background is a different location than the studio where they were filmed. This effect is one of the most used effects in filmmaking and live weather forecast in new broadcasts. So first we implement the 3 libraries that we are going to be using to the video capture object. We have the import num as MP, the import CV2, and cap equals to CV2.video capture 0. And then we have the frame per second FPS of the resolution of the USB webcam. This will be better frame rate and the green screen effect will look natural. So we cap set 3 to 640 and cap set 40 to 480. In the next step, we read the image that is we use to the background. So we use the BGCV2 and read and the location of our image. And then we have the write the familiar logic for the loop and read the frames. So we have the while true read frame equal to cap point read. I'm gonna run the program. So as you can see, we have the chroma key effect. In this case, is black color, but you can see in other chroma key effects that is blue or green. So see you in the next one.